Hello all and I welcome you to this new module. So in this module, we are going to learn about binary search trees. Now in the last couple of modules, we started with trees and then learned what binary trees are. Now binary search trees are a special kind of binary tree which has some property and the same is actually helpful in making some operations a lot more optimized and thus found a lots of application in the industry. So now let's get started and learn about what binary search trees or BSTs are. Now I have written the definition which we discussed in the types of binary tree video, where we learned that binary search tree BSTs are special kind of binary tree with following property. So the left subtree value of each and every node will be less than the root's value. The value of each and every node on the right subtree will be greater than root node's value, and these subtrees independently should also be BST. So if I have to draw that out, the same will be something like this. Now, just like trees, we have to still think of this in this structure. So each and every subtree is a binary tree in itself. Okay. Now, for an example, we can take this particular tree. So let's say this is some tree. Second, right. So let's say the root's value is 4. Then we have 3 as value of left and 2 is the value here. Then 8, 7 and 9. In this tree, we will see the property that root value is 4 and everything on the left of root is smaller. So 3 is smaller than 2, 3 is smaller than 4 and 2 is also smaller than 4, right? Along with that, this particular subtree, the left of it is smaller than it, right? So individually also we have to just see them as a separate tree, and for the whole tree to be BST, we should always make sure that they are also BST. Okay. Similarly, everything to the right of this subtree is greater than the root's value, which is 4. Along with that, this particular tree, the subtree, is also a BST, because if I see with respect to 8, 7 is smaller than 8, 9 is bigger than 8. Okay. So that is how our binary search trees are defined. Now, again, these are a lot overall inspired by the binary search algorithm. So we have already learned about binary search algorithm. So let me write this as well. Inspired by binary search algorithm. And if you all remember binary search algorithm, we learned that how it's an awesome algorithm which help us to move from ON complexity to O log n complexity in terms of searching, right? Now, one thing more, if I just ask you, is this a binary tree, BST? Let's say it is 5 here. This is 7. This is 9. And say it is 11. Well, if we see the property, this again is a binary search tree. Okay, because each and every node is following the property where the right tree or the right node is greater, and individually also it is a BST as well. This is not a overall well optimized tree. We have seen this already. This is a skewed tree. So here we might have some issue with respect to the complexity, but this is still a binary tree. Okay, so the overall understanding are those three properties which we talked about, these three properties which define what a binary search tree can be. Okay, so we have seen this specific type of a tree. It is a skewed BST, right? So here it might not be possible because height is of n. But if we are getting a balanced binary, if we are getting a balanced BST, then there we can say that we are able to reach the overall complexity of log n. Okay, So we will talk more about it, should be fine. Now let us see some real world example as well as industry use cases for binary search tree. First, let us talk about some real world example, everyone. Talking about real world example, the binary search tree are very much useful in, let's say, a phone book, the basic idea which we have here, right? So in phone book, if let's say we consider that each and every alphabet is a kind of a node, then in use cases such as phone book and dictionary, that is what we are applying, right? It is not where continuously things are kept, but we are able to make sure that because of binary search tree use case where we know that okay, towards the right everything is bigger, we can work on that. The next one is file searching. So in any OS, the overall files can be searched, right? And it is a lot more optimized. Many time it happens that in the backend, a BST is basically made so that the file searching can be made efficient. Many of you might have seen that in the OS, it asks you if the indexing can be done of the files, right? Which will help us to better search. So on that, basically, we can have this kind of an algorithm which transforms your file structure in the backend to a BST because that will be a lot more helpful. Okay. Along with that, in some cases, autocomplete feature, there also binary search tree are actually made. Okay. So in the back end overall, again, binary search trees are created because we know that how good the overall complexity is O log n with respect to On, right? So that example we have already seen. Now let us see some industry examples. The number one example in industry is the database indexing. So the reason we are able to search so quickly a lots of database query is that in the backend, overall a binary search tree can be easily maintained for the data. Okay. Then just like other trees, we can have a ML tree. So in ML we have the decision tree, right? In that as well, some use cases we are specifically creating a binary search tree when it has to do something with the values. Okay, so that is also something which we will see in if we learn about ML, then there is where it is normally talked about. The last one is many of us do the range queries, right? So range queries on our DB. So let's say in websites like Amazon, Flipkart, you are able to specify that, hey, I want the overall prices. Let's say you're looking for a phone and you say that I want these phones to be from 10,000 to 20,000. Then we are kind of doing a range query, right? In the DB. There also, the reason they are so fast is because binary search tree is getting used in the backend. Okay, everyone. So these are the few examples, real world and industry. Very much similar to the overall trees, but they are a lot optimized when they are done with respect to or with the help of your BSTs. Okay. So here it is file search, not file structure. Because in searching is where overall we are able to see the benefit. The structure of binary search allows us for efficient searching, insertion, and deletion. Okay, so another thing which I would like to talk about is that many of you, like, this is some doubt which I had, that if we already had an array which can be sorted and where we can store things, why do we learn about BSTs? Well, the reason is if you're trying to insert anything in an array, right, we have to shift a lot of things. Okay, we have to make space for any elements. Similarly, for deleting, if you're trying to delete, then also we have to do the same thing. But since in my trees, the overall nodes or the values, they are not connected or continuous, they can be anywhere and we can just refer them through next, through left or right. The same is very much helpful and doable. Something which we will be also doing in this particular module as well. Okay. So the structure of binary search tree allows us for efficient searching, insertion, and deletion. Okay. That is the major reason we are studying about BSTs. It's a very good concept from interview point of view. Many questions are asked because this is some overall, I would say, concept which is used in the industry. Okay. So the understanding which we had from the last two modules about the generic tree and the binary tree will of course be helpful, but BSTs found their use directly in the industry a lot. So it's very important that we understand each and every property as well as operation which can be performed on them in a lot depth. Okay, so I will make sure that each and everything in BSTs are clear to you, and towards the end of this module you will be able to create your own BST class as well, where you are supporting all the operations. Okay everyone, so I hope everything is clear now. Let's meet in the next video where we will start doing some operations on our BST. Thank you.